In order to understand how we hydraulically frack, or just fracking for short, we need to understand why we frack. We use the fracking process to extract natural gas out of low permeable oil shale formation that conventional oil and gas mining is ineffective at extracting. Conventional oil and gas extraction is a process that extracts natural gas through a vertical pipeline that punctures a hole through a high permeable oil shale formation. Natural gas then follows a pressure gradient that moves the gas from high pressure within the oil shale formation to a low pressure zone that is up the vertical pipeline where it can be collected and stored. This process is highly dependent on the permeability of the oil shale formation. If the oil shale formation has a low permeability, hydraulic fracturing must be utilized. The first step in hydraulic fracturing is to drill a vertical well 4,000 to 12,000 feet below the surface into a low permeable oil shale formation. This vertical well is then encased in 5 alternating layers of steel and concrete. A horizontal drilling derrick outfitted with gas sensors then drills a well horizontally into the low permeable oil shale formation. Next, large diesel pumps pump upwards of 3 million gallons of fracking fluid that is more than 90% water and 10% chemical additives that artificially reduce the water's friction and disinfect the water. This fluid is pumped into the oil shale formation at upwards of 5,000 psi, creating microcracks in which the natural gas can artificially permeate through. Sand and clay is pumped into the seam along with the fracking fluid to help widen the microcracks and keep them from closing. This process is repeated upwards of 20 times until all natural gas is extracted or until it is not economically sustainable. After the injection of the fracking fluid, wastewater rises out of the well. The rate and time period from which the wastewater rises out of the wellbore is highly erratic and has a high probability of leaking and being dissolved into surrounding aquifers. This wastewater has extreme concentrations of heavy metals, naturally occurring salts, radioactive materials, chemical additives, and dissolved methane. This water is highly toxic, currently untreatable, and raises a concern for the unknown long-term effects from the possible contamination of fracking wastewater on drinking water and aquifers. The collected wastewater is then stored in underground depositories or an off-site facility. Hydraulic fracturing is a new technology that was developed in the 1940s but recently been innovated to handle high quantities of natural gas. Around 50% of all natural gas wells employ the use of hydraulic fracturing over conventional oil and gas wellbores, and a projected of 80% of all future natural gas wells will use the hydraulic fracturing process to extract natural gas. The use of fracking for natural gas has lowered energy costs since the creation of the open energy market in 1999. One study done on whether fracking should stop or not found that the natural gas industry in America accounts for US $385 billion in direct economic activity and nearly 3 million jobs annually.